I already made a video on this worksheet last week, but I want to go over this a little bit more over completing the square. Now, what is completing the square? It's really where you take and find your perfect C value that would make it a perfect square quadratic trinomial. We love perfect square quadratic trinomials. We love them. Why is that? Well, if you have a perfect square quadratic trinomial, like let's say number 7 right here, for example, this is a perfect square quadratic trinomial, which means that we could factor it. What times what is C? That if you combine together is B. That will be a -3 and a -3. Okay, now you could make a list if you want to, but it's pretty obvious. What times what is 9? That if you combine together is -6. That'd be a -3 and a -3. So what we have here is a perfect square quadratic trinomial, and we love those. Why? Because you're going to be able to write them as a binomial squared, because you have the same identical binomial. So instead of writing it the same binomial times the same binomial, you might as well just write it once and put a square on it. Everybody with me? And of course, it's equal to 7. Now, why do we like this situation? Why do we want a binomial squared? Because then you could just solve by getting rid of things, by doing the opposite. And how would you get rid of this square? What's the opposite of a square? A square root. So you apply a square root, and what you do to one side, you must do to the other. And I hope everybody remembers that when you apply a square root in an equation, what must I put in front of my answer? Plus or minus. You have to put the plus or minus. Now, if this would have been the square root of 8, I would have to rewrite it, break it down with multiplication. But 7, you can't break it down. It's not a perfect square number, and you can't rewrite it with multiplication to get a perfect square number. So you just leave it, square root of 7. Everybody with me? Final step is to add 3. Add 3. And whenever you have a number with a plus or minus, it doesn't matter if it's a square root or imaginary or even a nice number, always rewrite this one first and the plus or minus whatever second. So let's write our answer that way. X equals 3 plus or minus square root of 7. That's it. You're done. That's the answer. Okay? Now, this is why we love perfect square quadratic trinomials. If you have the perfect C value here and it works out as a perfect square quadratic trinomial, you're going to end up being able to rewrite it as a binomial squared, which is pretty easy from there on. So we love perfect square quadratic trinomials, but the fact is most of the time we don't have perfect square quadratic trinomials, right? It just doesn't happen. Bless you. So this is why we learned the method called completing the square. Like down here, I think we already did numbers 9 and 10 on the previous video, but it's just practice. Bless you. It's just practice. How do you find the perfect C value based off of this middle number? Do you guys remember how to do that? B over 2 squared, right? The perfect C value comes from taking your B value, dividing it by 2, and then multiplying it with itself. This is what we need to know. It's like a little formula for completing the square. So I need to take the B value of 24, divide it by 2, which gives us 12, and then squaring it, which would give us the perfect C value of 144, right? 24 divided by 2 squared, that'll be 12 squared, which is 144. So the perfect C value, this guy, the perfect C value is 144. So they want you to find that perfect C value. Why? So you could rewrite it as a binomial squared. So on the back of the worksheet, they're going to give you this answer, 144, but they also want it in factored form as a binomial squared. So do we remember what goes inside the parenthesis? We're going to have an x, and what belongs with the x right here? Do I put the 144 in here? No. We take half of whatever B is. So right here, B is 24. So what belongs in here? 12. That's right, a plus 12. So let's understand that. Let's not forget it. Whatever your B value is, like if it would have been a -8, right here you'd have a -4. This would have been a -12, right here it'd be a -6. You just put half of whatever you see right here, half of it right in here, into your binomial squared format. So the answer on the back of your worksheet, yeah, the perfect C value is 144, and also the factored form of the quadratic trinomial, perfect square quadratic trinomial, would be in parentheses x plus 12 on the outside square. Now, as you can see, finding that perfect C value is very easy when your B value is divisible by 2. But it's not so easy when your B value is odd. Okay, like right there, this is horrible. If we think about what's my perfect C value? Oh, I need to take B, which is 5, divided by 2, and then square it. How ugly is that going to be? Think about it. 5 divided by 2, and then squaring it. You'd have to actually write the fraction 2 times. 5 halves times 5 halves, giving you 25 over 4. So that's my perfect C value. My perfect C value is 25 over 4. And why would I want that perfect C value? That way I could write it as a binomial squared. Inside the binomial, you have the x. And what else belongs inside of the x? What belongs inside of the x? With the x, inside of the parentheses. 2.5 or 5 halves, right? It's simply going to be half of whatever you see here. Because it's positive, it will be a positive. And 5 divided by 2 is exactly that, 5 divided by 2. Or you could put it as a decimal, 2.5, totally up to you. So on this answer, number 12, yeah, your perfect C value is 25 over 4, but the factored form, binomial squared, is going to be x plus 5 halves to the second power. Or you could put x plus 2.5, totally up to you. Make sense? So as you can see, it's nice, completing the square is nice when your B value's even, and it's a lot more challenging when your B value's odd. Okay? The final part, they want you to solve each equation by completing the square. Now, I say, forget that. Let's not solve each equation by completing the square. How about solve some equations by completing the square? Okay, see, what they're saying right here with these instructions, solve each equation by completing the square, that's like saying, here, I'll give you a tool. Here's a shovel, all right? You got a shovel, and I want you to hammer these nails into this piece of wood. Right? That's a horrible tool for that job. But if I give you a shovel and I say I want you to dig a hole, that's great. Right? So the bottom line is you guys right now already have a bunch of different tools, different factoring tools, right? And you're going to use different factoring tools to solve different types of questions. For example, if you try to complete the square right here on this one, that'd be horrible. That's a horrible method. That's a horrible tool to use. That'd be like the equivalent of me saying, yeah, here's some nails, hammer them in with this shovel. That's a very, very bad idea. What's the right tool for number 16? Not completing the square method. GCF, thank you very much. If I pull out that GCF, what's the GCF? X, what would be left over on the inside? X plus 3. And this would still be an equation equal to 0. So because we have something times something and it equals 0, we could say that that first something could be equal to 0, or the second something could be equal to 0. Using the zero product property, that is, you could split them and solve. This one's already solved for you. This one, the answer will be -3. So those are your two answers. How easy was that? That was amazing, right? Now, could you imagine if I tried to complete the square? I'd have to first make sure my A value is 1. I'd have to do 3 divided by 2 and then square it. Dang, that would be 9/4. That'd be ugly. I mean, just forget about it, right? Completing the square is horrible on this one. It's a lot easier to use a different tool, like pulling out the GCF. So, would completing the square be good right here? Heck no. Why not? Because the B value is 1. So when you try to find the perfect C value, when you say, oh, B divided by 2, you get 1/2. And then 1/2 squared is 1/4. That's ugly, right? So completing the square is not the best tool to use on this one. Which one's the best tool to use on this one? You can't pull out a GCF, but there's other factoring methods. The A value is 1. So why not jump right into this? Right? What times what is -6 that if you combine together, what times what is -6, the C value, that if you combine together is +1, the B value? 3 and 2, right? Which one's positive, which one's negative? +3, -2, right? So that's really easy to factor, might as well factor. And then split it and solve, which will give you your two answers. x equals -3, x equals +2. So again, I want to emphasize this. Completing the square is a great tool for certain jobs, not for all the jobs. Like, so right here, it would be really dumb to use completing the square on this one. It's way easier to just factor, split, and solve. Okay? Would this one be good with completing the square? Well, yeah, because the b value is even, so you could divide by 2. But before that, you should take a moment and think, okay, could I multiply what times what is -13 that if I combine together is a b value -4? It doesn't work, right? So yeah, right here, I mean, completing the square is your only option, because if you try a different factoring method, you can't do it. So let's complete the square on this one. Let's actually do it. Step 1 on completing the square is to make sure the a value is 1, which it is, and also make space for your new c value. So how do I make space for that new c value? I don't want that old c value. I need to get rid of it. Add 13 to both sides. So let's rewrite it. X squared minus 4x. Here's my new blank spot for my new c value equals 13. I might as well put that blank spot over there too, because I know I need to add it to both sides to maintain the balance, right? So at this point, I am going to ask, what is my b value? Oh, that's -4. I need to find my perfect c value, I need to take b, divide it by 2, and then multiply it with itself. So we end up with -2, or let me show my work. -4 divided by 2, that is -2, and then I need to square it. What do I get? +4, right? So let's put a +4 right there and a +4 over here. That way you maintain equality, you maintain the balance of this original equation. And now that we have a perfect c value right here based off of this b value, this is now a perfect square quadratic trinomial, which I will be able to write as a binomial squared. And what belongs inside of the parentheses? X minus 2. The -2 is simply just half of whatever you see as your b. So since you have a -4x as your b, it's just going to be a -2 in there. And on the right side of the equal sign, we have a 17. So now that I have a binomial squared on a square root both sides, I will have x minus 2 equals, don't forget the plus or minus, square root of 17. Final step would be to get rid of that -2 by adding 2, adding 2. Never try to add and subtract in your head. Always rewrite, even if you could do it. Right here, I'm going to rewrite it. X equals 2 plus or minus square root of 17. Normally, you try to reduce the square root of 17. Like if it were the square root of 16, that would be 4. And you'd be able to go 2 plus 4 and 2 minus 4. But it's not 16 to 17. If you add the square root of, let's say, 12, you could break it down to 4 times 3. 17, you can't break down to anything. So you just leave it like that. That is your final answer. Okay. So 18 was a great problem for completing the square because we have no other method, right? So which other one on this whole worksheet would you say is nice to complete the square with? 24? Definitely. That's a good one to complete the square with. Why? Because the b value is divisible by 2, right? So when you do half of b and square it, you'll be able to do it nice and easy. And you can make space by subtracting 4, subtracting 4. So please use completing the square on number 24. Is there any other one I could use completing the square? What about this guy? The b value is divisible by 2 right there. Is that a good one for completing the square? Heck no. Why not? Because in order to complete the square, in order to use this method, your a value, it's a fly, your a value has to be 1. So you would have to divide everything by 3 first, right? So don't do this, right? Don't do this. But imagine if I were to divide by 3, divide by 3, divide by 3, divide by 3, you'd have your new equation x squared plus 2/3 x minus 1/3 equals 0. And to complete the square, you'd have to add 1/3, add 1/3, cancel out, make space for your new c value. Like I said, don't do this. Here's the space for your new c value. Then you'd have to take half of b, half of a fraction, so it gets more complicated, and then square it, and you'd end up with a really ugly fraction, right? So this is not a good tool to use on this equation. So please do not complete the square on this equation, okay? So let's not use completing the square on this one. What other tool do you have that'll help us solve this equation? A times c. All right, so everybody write down step 1. Let's do 20 together. Write down step 1 and go ahead and multiply A times C. Yep, and what do we get? -3. Thank you very much. Step 2 is to think of the multiples of -3 that combine together to give you the B value. And I say make a list, but the only way to get -3 is -1 times 3, right? And that's it. So that is the correct pair of numbers that combine together to give you B. So instead of writing it as 4 terms to use factoring by grouping, let's use that latest shortcut that we just learned, that magical shortcut. Step 3 would be to rewrite it in your factored form format with AX as the first part of your binomials. And what belongs in this empty space right here? -1 and +3. The pair of numbers from step 2, just plop them right in there. -1, +3. The fourth magical step that we need to apply is what? Divide this if possible. Is there anything to divide it by? No, so I'm just going to leave that first binomial exactly the way it is. How about this second one? Divide by 3, and what do we get? 1x plus 1. That's completely factored, but this is an equation that was originally equal to 0, so I still have the equal 0. Now all I have to do is split it and solve, right? So I have 3x minus 1 could equal 0. X plus 1 could equal 0. Plus 1, you're going to have 3x equals 1. Divide by 3, x equals 1/3. That's one answer. And over here, subtract 1, x equals -1. So those are your two answers for number 20. So this was an example where completing the square is a horrible tool for this problem. The shortcut that we just learned, that's a better tool to fixing this problem, right? All right. Let's jump to number 22. Now, the reason why I go to 22 is because, is it going to be easy to complete the square right here? No, the b value is not divisible by 2. So it's going to be a fraction. It's going to be a little ugly, but we're going to go through with it anyway. I mean, when you see that the b value is odd, you're supposed to try a different factoring method. But if you tried to do this, and you think what times what is the c value that if you combine together is the b value, you're not going to find it because it's not factorable. All right, so you're actually stuck. It's not factorable. So you are forced to use completing the square method. So completing the square method, let's do this together on number 22. The a value is 1. It's ready to go. I first need to make space for my new c value. So I need to get rid of that -3 by adding 3. Adding 3. I want to rewrite it. X squared minus 1x space equals 3 space. So how do I get that perfect c value? I'm simply going to take b, divide it by 2, and then multiply it with itself. So my b value happens to be -1. So I'm really going to have -1 divided by 2 and then squared, which is really a -1/2 times a -1/2. So what's -1/2 times -1/2? 1/4. So my perfect c value is +1/4. So everybody put a plus 1/4 right here in this perfect c value spot that we have. And what you do to one side, you must do to the other side. Put plus 1/4 over here. Sorry. And now that we have a perfect square quadratic trinomial with a disgusting fraction, we could rewrite it as a binomial squared. So what's inside the parentheses? You have the x. And what else do you have right here? Minus half of whatever you see here. Minus because it's a negative. Half of 1 is 1/2. So yes, Yael, you got it. It's -1/2 right in there. And it is equal to what? It's equal to, what is 3 plus 1/4? It's simply 3 1/4. Okay, now, why would I want a binomial squared? Why did I complete the square? So I could have something squared, so I could get rid of it with the square root, correct? But before getting rid of the square with the square root, I see this mixed number, and I'm going to change it to an improper fraction. So how do I do that? 4 times 3 is what? Plus 1? So let's change it. Change the right side of this equation to a 13/4. That way, when I apply a square root to get rid of the square, it'll be easier to deal with the fraction, an improper fraction, than a mixed number. So right here, when I take a square root, I have a new equation that reads x minus 1/2, no more square root, it eliminated, equals, when you apply a square root in an equation, what must you never forget? Plus or minus, okay. And then when you have the square root of a fraction, you could take that square root and split it to each of them, which you should do. So you're going to have the square root of 13, which can't be done. It's just the square root of 13. But you have the square root of 4, which is really what? 2. So what we really have down here is a plus or minus fraction with the square root of 13 up on top and a 2 on the bottom. Now for my final step, to get x by itself, I need to add 1/2, and then rewrite before anything else. X equals positive 1/2 plus or minus square root of 13 over 2. Now this is, ladies and gentlemen, the correct answer. However, in the back of the book, since you have two fractions that we're supposed to add and subtract and they have the same denominator, they write this as one single fraction over that same denominator. So the back of the worksheet solution is you're going to see this. X equals 1 plus or minus square root of 13 all divided by 2. That's what they have. Either one is correct, all right? So on my open response quiz, either one is correct. So completing the square works out beautifully when your b value is divisible by 2. It'll work out beautifully right here on number 24. And if it's not there, if the b value is not divisible by 2, try a different method. And if you can't find any other method, then yeah, try completing the square, right? Again, completing the square is just a tool. It's like a shovel. Right here, 23, completing the square. Would it be smart? Would it be the right tool to use, completing the square on number 23? Heck no. What's the tool to use? Square root. All you got to do is square root both sides. So if you square root here and square root there, you have x equals plus or minus what? I square root of 11. You're done. I mean, could you imagine doing any other way? Heck no. Why would you do any other way when this is like the easiest? So you have all these different factoring tools that you've already learned. Completing the square is just one of those new tools. Only use it when it helps you, or when the b value is divisible by 2, or when you have to, like we did over here on this one. So this is a long video, but it did explain the majority of the homework questions that we had to do. We also have another assignment from the book. It seems like a ridiculously long assignment, but it's not. Page 260 from the book. So if you finish the worksheet, you could jump and get yourself a book from the front. Turn to page 260, do numbers 9, 12, 19, 30, 32, 33, 39, 40, 41. Now, of course, I picked these because, like I said, a lot of them, completing the square is not a good idea to use. Most of these completing the square, did I say perfect square? Completing the square, most of these is a great option for these. It is a good tool for these questions. All right, so that's why I picked specific questions. Not only that, on the majority of these, you're going to end up with an imaginary value as well. Okay, so these are great problems to do. If you want to check your answers, I have the solutions posted right here at the back. So here are the answers. So like I said, it's not too much work. It's only like one page's worth. And some of them, like I said, they were handpicked. Most of them are great for completing the square, so you could practice completing the square. But there are some, like 32, where you could just jump right into factoring, splitting, and solving. Same thing with 33. But the majority of these, completing the square is great. That's why I picked them. So the answers are right here. They're on the back of the wall. They're also uploaded to PDF onto Edmodo in case you need it.